So in this fairly brief video, I'm going to be going through how we can add, subtract, and multiply polynomials together, including scalar multiplication. So in this particular example, we have a polynomial p1 and a polynomial p2 defined in terms of x, and we have to determine expressions for when we add them together. If we do 3 times the first one, take away the second one, and if we multiply them together. Do note that this particular notation I will be using quite a lot. So when I mean p1 dot p2, that's the same as p1 multiplied by p2. The reason I don't include this x is because if I were to do x times x, it looks a bit clunky. So whenever I do it, I prefer x with a dot in the middle, x. So you can give this problem a try. If you've done even decently well at junior cert, this should be fairly straightforward, but I shall still go through it. So p1 plus p2 is the first polynomial, x squared plus 2x take away 5, plus the second one, which is x cubed take away 4x squared take away 8. So all we're going to do is, just like in the beginning of first year, we're going to be collecting like terms. So we have p1 plus p2 equals, well, there's only one cubic term, there's only 1 to the power of 3, so that gets its own spot. So anytime I tend to do this, I have little shapes underneath all the similar terms. So there's that one x cubed, now there's two sets of x squareds, there's this x squared and the minus 4x squared. So 1 take away 4, that's minus 3x squared. There's only one x term, so we just write plus 2x. And then there's just a constant term, which, just be careful of the fact that this is a plus and a minus. So plus minus, you get a minus. So we get negative 5 subtract 8, which is negative 13. And note that in this particular case, the degree of the sum of these polynomials is just the highest degree that appears in either one of the individual polynomials. This is not always true because you could get a cancellation somewhere. But if there's no cancellation, if there's no cancellation of the highest term, then the degree, which we write as deg, of p1 plus p2 is simply the maximum value of either the degree of p1 or the degree of p2, whichever one is larger. This also holds true for when we're subtracting them. So if we want 3p1 minus p2, p1 we can write as x squared plus 2x minus 5, and then subtract p2, which is x cubed take away 4x squared take away 8. So whenever we have a number in front of a polynomial expression, it pretty much just jumps in and hits every single term individually. So we get a 3x squared plus 6x take away 15. And then anytime we have a subtraction, think of this as like a minus 1 sort of hiding in there. So we have minus 1 multiplying with all that, so we get negative x cubed plus 4x squared plus 8. So now what we'll do is, again, we'll just collect the terms. So we have an x cubed, that's the only x cubed you have there, so we have a minus x cubed. X squareds, well, we have a 3 and a 4, so adding them together we get plus 7x squared. The x's, again, we only have one x term, so that's plus 6x. And then 8 take away 15 gives us a minus 7. So that's the polynomial expression of 3p1 minus p2. And again, it's the same thing. The degree of even any scalar multiple of p1 minus p2 is still just the maximum value of the degree of p1 or the degree of p2, whichever one is naturally larger. Okay, we'll now move on to the last calculation, which is p1 times p2. So we have x squared take away plus 2x minus 5 times x cubed take away 4x squared take away 8. Now there's a number of different ways of doing this. So the way I will do it is just take each term individually and multiply with each successive term in the other bracket. So what I mean by that is we'll do x squared multiplied by everything. So this term multiplied by this bracket. So we get x squared times x cubed, which is x to the 5. X squared times minus 4x squared is minus 4x to the power of 4. And then x squared times minus 8 gives us minus 8x squared. Next we'll do the same with the 2x, so we have plus 2x times x cubed gives us x to the 4. 2x times minus 4x squared is minus 8x cubed. And then 2x times minus 8 is minus 16x. And then finally we have the minus 5, so we have minus 5x cubed plus 20x squared plus 40. So we're now going to gather the terms as before. There's only one x to the 5, so that goes in there. In this case, I'll just kind of cross them off. In an exam, make sure this is done very faintly. Now, how many x to the 4s? Well, we have plus 2 and a minus 4, so that's minus 2x to the 4. So they're going to say goodbye to each other. How many x cubed? Well, we have minus 8 and minus another 5, so minus 13x cubed. So they're going to go. X squareds, we have 20 minus 8, so plus 12x squared. And then the other two are by themselves, so minus 16x plus 40. And again, there's something fairly interesting that we can spot. The degree of any time we multiply two polynomials is simply the sum of the two individual degrees. Because we had a degree 2 polynomial multiplying with a degree 3 polynomial, and when we multiply these things with the same base, we add the powers. So the degree of when we multiply them is simply the sum of the individual degrees.